So we left off on this problem here. Stop talking, please. And I think at the end I realized that I wrote something down wrong because this did not come out to be what I thought it was going to be. So let me double check that and find the example problem that I stole this from. Where did you go? Cotangent. Yes, that's written down correctly. It is. What did I... Oh, that's my oopsie McDaisies. Okay. So, this is... Let's not do this step here. We'll salvage it from here. Okay? I screwed that. I mean, that is correct what we've written, except I should have cotangent squared. But rather than doing that, I'm going to do something different here because it's going to be a little bit easier to deal with. Is everybody okay? So we're just... It was this problem that we ended with yesterday. So I'm just picking up at that last step where we were yesterday. Okay. So I'm going to rewrite this now in terms of sines and cosines. So the numerator becomes 2 times 1 over cosine. And the denominator becomes sine squared over cosine squared. So this is a division of fractions problem. So I'll divide fractions. That's easy as pie. You flip the bottom and multiply. So there I have my 2. And now if I look at this piece, I'm going to do something a little weird, but I'm going to write this as cosine x over sine x times 1 over sine x. Is everybody okay with seeing why those two things are still equal? You might ask me, hold on a second, Mr. Kulik. Why in God's name would I want it to do that? And that's a fair question. So I would refer you to what are we trying to get to? My goal is to have 2 cotangent x cosecant x. Remember, this is where we're trying to get to. So I see that I have the 2. Check. Cosine over sine. What is that? Cotangent. Got that. Check. And 1 over sine. What is that? Cosecant. Check. So we do have exactly what I needed. It was just a question of pulling it apart of what was there. Is that okay with you guys? Let's do some more on this again. Not a familiar looking skill. So let's do lots of practice and try to build up a little bit of intuition. So here we have cosine x over 1 minus sine x equals 1 plus sine x over cosine x. These are about equivalently complicated. You guys kind of agree with that? But I would still wager, or still say that one of these sides is better to work on than the other. I would still say that this side is a little bit more complicated than the other, in that its denominator has addition and subtraction in it. Remember that if we have like the right-hand side, because the denominator is a single thing, we could just write that as two things with common denominators like this, and we can kind of break the fraction up at the addition symbol. We can't do that when the addition and subtraction is in the denominator, though. For that one, you have to, there's not really anything, no way you can break it apart. So you guys kind of okay with that idea? So that's why I'm going to work on the yellow side first. Everybody's all right with that idea? So if I'm choosing to work on the yellow side first, my goal, the place where I'm going to focus, is trying to get 1 minus sine to have cosines in it. That's what I'm going to focus on. Is everybody okay with that plan? So I'm going to worry about trying to get the denominator at least to have a cosine in it. So 1 minus sine x looks close to something that is related to cosine, right? I remember that 1 minus sine squared is cosine squared. Is everybody okay with that idea? You remember that identity? That's what I'm going to try to do. So what do I need to do to this fraction here to get the denominator to be 1 minus sine squared? Well, I'm going to multiply the top and bottom of it by something. What should I multiply the top and bottom of this fraction by? Not sine, because when I multiply sine, it's going to have to distribute. And I'd have to multiply to each of these two, so I'd end up with sine minus sine squared, and not 1 minus sine squared. So sine alone isn't going to hack it. 1 plus sine, though, will do. So when I multiply here, the cosine needs to distribute. And when I multiply the denominator, what's going to happen down here? I'm going to have to FOIL. Are we okay with this plan? So again, we're using that difference of 2 squares kind of formula going on here again, right? When I FOIL that out, I get 1 minus sine x plus sine x minus sine squared x. And notice something rather nice happens in the denominator, don't you? And in the denominator now I have 1 minus sine squared. What is that? Cosine squared. And if I look at the denominator, each term has a factor of cosine in it, correct? What if I factor that off? What am I going to be left with? And now, what can we do? And we're at our final destination there. in math? What do you think? Still see some more? Why not, right? Doesn't hurt nothing. What about... how about this one? Well, which side do you think you want to work on here? You want to work on the left side, I heard somebody say? They both look ugly. I agree. I don't think that there's one that's an obvious choice here. I think, me personally, it's probably, I don't know. Doesn't really matter, I don't think. I guess let's work on, for the sake of argument, let's work on the left side. And I'll tell you what I'm going to be concerned about immediately. It's going to be trying to get rid of that denominator there. So just like in the previous example, I'm going to try to get that down into a single trig function. How can I do that? I'm going to multiply the top and bottom of it by 1 minus cosecant squared. I'm sorry, just 1 minus cosecant. So I end up with 1 minus cosecant squared. And if I look at my identity sheet, what is 1 minus cosecant squared equal to? It's tricky to see this. You're close. So somebody said cotangent squared, and they're using this identity, right? But to do that, I have to subtract cosecant squared onto this side and cotangent squared onto the other side. So what am I really getting in the denominator? Negative cotangent squared. And I guess, what can you notice now? Well, what I'm going to do is I'm going to think about pushing this negative sign up into the numerator. So everything in the numerator now switches signs. Is everybody okay with that? And what am I trying to head to? Well, I need a cotangent on the outside. So maybe I take one of these cotangents and I'm going to pull that out. Everybody okay there? I notice that I have cotangent in each of these, so maybe I do that. And now I'm going to write these as two separate fractions. And it's okay to do that because the denominator is just one thing, right? I notice this thing is, that's my tangent. And this thing is 1 over sine over cosine over sine. So when I flip them and multiply, I'm left with 1 over cosine, which is just secant. And that's what I was looking for. Oh, this is amazing. We have so many problems to do. All right, for tomorrow on page 418 to 419, I'd like you guys to do 11 to 51 every other odd. So do 11, skip 13, do 15, skip 17, do 19, etc. We've done this before, right, guys? Okay, let's get that 51. Whoa! Where's trig in my classes?
I think you're still recording.
Oh, I am? That's a good point.